Okay, this presentation focuses on bias in reinforcement learning. So we're talking about machine learning ethics, but focusing on the way that bias can show up in a specific type of machine learning reinforcement learning. Okay, and we'll use our familiar framework, although I'm going to kind of combine items 3 and 4 here in this presentation. Okay, so reinforcement learning, it is a type of machine learning, but it doesn't fundamentally learn from examples. Now, when I talk about solutions, I'll give you a way that it can, but not essentially that's not the case. And it doesn't matter whether these examples are labeled as in supervised machine learning or unlabeled as in unsupervised machine learning, right? So the data set is not given to it. So other kinds of machine learning, the kind that are more often spoken of, supervised and unsupervised, what is essential is that the algorithm consumes examples that are given to it. This is different because we can think of the reinforcement learning agent as enacting trajectories, right? It observes states, takes actions, and gets reward. And so one of those trajectories is essentially an example. And a bunch of those trajectories together essentially becomes its training data. So it generates its own training data. Let's think about this in terms of a chess playing model. So it's everyone's favorite example to think about, right? Chess playing. So there's these really dramatic, fun to think about, understand examples of supervised machine learning model, learning how, trying, and then learning how to beat a human in chess. So what happens in these models, or what happened, is that the model was trained on historical games, and eventually you give it enough historical games, and it develops a kind of strategy, and so it becomes a formidable opponent. Now, one thing that happened is, this chess playing agent, they, instead of supervised machine learning of providing it historical examples, they said, hey, why don't you just learn how to play chess by playing against yourself? And it turns out that in this particular context, chess, this was a more efficient way for the agent to learn. It learned from examples that it itself generated. And I'm saying that's different than the supervised or unsupervised models. Okay, so what is familiar about this problem? So other videos that I've produced here that you may have watched, I've produced quite a few videos about bias, data bias, and algorithmic bias. I have series on both of those. And so, the assumption there, I didn't make this explicit, but the assumption there was we were talking about models that weren't reinforcement learning models, okay? So, there are ways we can kind of compare other examples of bias to reinforcement learning. For example, the data bias videos, it's like there is a kind of data in reinforcement learning, the trajectories I just talked about. But in data bias, I was talking specifically about examples, how the examples are biased. They can be biased because they're not representative of what they're supposed to represent. They can be biased because they're historically biased, or they can be cleaned in a way that makes them biased. But reinforcement learning doesn't have examples, it has trajectories. I talked quite a bit in other videos about design bias. But the design of systems, besides the data, we have like parameters that we need to choose. And that's true for supervised and unsupervised learning. And there is something about the design of reinforcement learning systems that's important, but we don't have parameters exactly. We have environments and rewards that we need to design. And I also talk about emergent bias. So some people classify emergent bias as a separate type of bias. I think of it as a subset of design bias, and the reason is because good design should anticipate when the system is misused. whether intentionally or unintentionally. And yes, not if, but when. Okay, but you can also think of it as a separate type of bias. And there's the emergent bias in that sense with supervised and unsupervised learning came from the users of the system. And there is a kind of bias that can emerge, but from the agent, not the users of the system. So these are like, you can kind of like, see the similarities, but they're more like analogies than similarities. Calling it a similarity is sort of attempting to say, but they're just different kinds of things, right? The bias in reinforcement learning, yes, there is bias. And yes, there's bias in other kinds of machine learning, but it is so different that you need to talk about it differently. You can't just like say, we have already talked about this. No, it's a different conversation. So that's why there's a different video here. Okay, so the three type of bias that I've already mentioned this, but bias can come from the way that the environment is constructed. So the environment has to be constructed by some designer who have their own assumptions, and that can shape the environment. The designer of a reinforcement learning system also has to design the rewards. And again, these very well reflect some assumptions of the designers that we don't want it to reflect. And there's another bias, I call it, we call it emergent bias from the way that the system is misused. Here, let's just call it exploration bias because the agent has to explore the environment. But how the agent explores the environment can reinforce patterns that we don't want to be reinforced. Okay, so those are like the general three types of bias in reinforcement learning. I'd like to talk a little more about each of those best practices for it. I'm again skipping the which value is relevant here because the value is fairness, of course. Okay, so I have some general best practices, and if you've already watched the other video on the problem misalignment, you've seen these already. That's why they're general, because you can kind of use them for either problem. But I also want to talk about specific best practices relevant to the three categories of bias in a moment. Okay, so bias audits are useful. You can check for disparities. Transparency is useful here to understand what the agent's policy is, what it has updated its policy to, and then you can audit the policy. And again, you can use supervised learning to supplement what you're doing with reinforcement learning, kind of preload it with some data that you trust, that you believe is fair, to kind of give it a place to start. Okay, let's talk about each of the specific kinds of bias or the sources of bias in reinforcement learning. So one is from the environment. So how do you make sure that your environment doesn't introduce bias into your model? Well, one is auditing the environment, testing for representational fairness, making sure that the right groups or items show up in the environment and how often they show up. Randomizing the domain. So, you can think about this as the classic machine learning problem of overfitting, right? Overfitting is when a model, an algorithm learns the data, but its learning is based on the specific data that it has. And so then when it tries to generalize to other sources of similar data, it can't do so. It's like the student who memorizes an exact set of answers, but then can't apply them to other similar questions because they don't have a general understanding. They just have the answers memorized. Okay, so we might want to expose the agent to varied environments so it doesn't get too tied to a specific environment. Counterfactual environments. So specifically introducing environments that reflect other kinds of conditions, and then we can compare how the agent explored in one environment to how the agent explored in the other. All right, bias can also come from the way the reward is designed. So we can introduce fairness constraints into as the agent gets the rewards, It's not just maximizing one kind of value, but there are other constraints on how it maximizes. Giving it multiple kinds of rewards, so not just efficiency, but other things that we care about ethically, fairness and safety. And using humans, and again, this was like a general strategy in the context of misaligned rewards. But using human beings, not all human beings can agree on every single value, but there are a subset of values that human beings in general can agree on, and that's a way to check to make sure that the system isn't developing some undesirable biases. Okay, and bias also comes from the way that the agent explores the environment. So we can give it something that we can call coverage guarantees. So this is some kind of assurance that the agent will eventually explore everything, or at least account for everything into its learning, right? So it doesn't like just get caught up in exploring this area over here and all of its learning occurs from this exploration. It explores everything that it needs to. Similarly, this isn't way different, but the diversity promoting exploration, making sure that the agent explores different kinds of states and subgroups, and then stress testing and adversarial training. Okay, so purposely introducing worst case scenarios for the agent to deal with so that we know what happens when it's put to the test. And this can surface blind spots. All right, so these are some notes about the problem of bias in reinforcement learning.